Hey everyone, welcome back to iTower. In today's video, we're going to explore two foundational data structures in computer science, stack and queue. These are super important to understand if you're learning algorithms, working with data flow, or even building real applications. Once you get a solid grasp of them, you'll start seeing them everywhere, from undo and redo systems to task scheduling and more. Before we jump into the code, make sure to like the video if you're excited about this topic, and don't forget to subscribe to the channel. It really helps the channel grow and you stay up to date with all our tutorials. Alright, let's get started. We will begin by understanding what a stack is. A stack works just like a stack of plates. The last one you put on top is the first one you take off. This is called last in, first out. Imagine you're using a browser and clicking through pages. Every time you visit a new page, it's added to the top of the history stack. And when you click back, you go to the last page you visited. Stacks are used in a lot of real-world scenarios. They're perfect for undo and redo features in editors, managing function calls with recursion, parsing expressions, and more. The two key operations in a stack are called push and pop. Push adds an element to the top, and pop removes the top element. Now let's create a simple stack in JavaScript and break it down together. We're defining a class called stack. Inside the constructor, we create an empty array that will store all our elements. This array is what we'll use to simulate the stack behavior. The push method adds a new element to the end of the array. Since JavaScript arrays are dynamic, this operation is very fast. In terms of time complexity, it takes constant time, or what we call order of 1. The pop method removes the last element. It works just like removing the top plate from the stack. Again, this is a constant time operation, order of 1, which means it's very efficient. The pick method lets us look at the top element without removing it. We do this by accessing the last item in the array using its length -1. The isEmpty method just checks if the stack is empty by seeing if the array's length is 0. If there are no items, the stack is empty. Let's try using this stack now. Here we create a new stack and add two elements to it, 10 and 20. Since 20 was added last, it's at the top. When we call pop, we remove and return 20. Then we call peek to check what's now on top, and it's 10. You can imagine how this applies in real life. For example, if you're building a calculator app, every time you input an operation like 2 plus 3 times 5, you can use a stack to evaluate the expression in the correct order using postfix notation. Also, stacks are essential in managing function calls during recursion. Every time a function calls itself, the current state is pushed onto the call stack. When the function finishes, its state is popped off the stack. Now let's move on to queue. A queue works like a line at the grocery store. The first person to get in line is the first to be served. This is called first in, first out. Queues are great for handling tasks in the order they arrive. Let's build a simple queue in JavaScript. Here we have a class called queue. Just like the stack, we use an array to store the items. The enqueue method adds an item to the end of the array. That's like someone joining the end of the line. This is a fast operation that runs in constant time, order of 1. The dequeue method removes the first item in the array. That's like letting the person at the front of the line go first. This operation takes linear time, or order of n, because JavaScript has to shift all the remaining items one place to the left. If performance is a concern, we could implement a queue using a linked list or a circular buffer instead. The from method lets us look at the first item in line without removing it. The isEmpty method simply checks if the queue has any items by comparing the array's length to 0. Let's see how this works. We add two tasks to the queue, task 1 and task 2. When we call dequeue, we remove and return the first one, task 1. Then we call front to check what's next, and that's task 2. Queues are everywhere in software. On the back end, they're used to manage background jobs, like sending emails or processing payments. In front-end apps, you might use a queue to handle notifications, throttle user events, or manage animations. Even React's rendering engine uses a queue-like structure to prioritize updates. Now let's think about where stack and queue are used in real-world applications. In games, stacks manage game states or screens, like when you pause and unpause the game. In browsers, the back and forward buttons rely on a stack to track navigation history. In operating systems, queues manage tasks in the CPU scheduler, often using round-robin algorithms. Even in APIs, message queues help control the flow of data between services. So when should you use one over the other? Use a stack when you need to reverse something, track nested operations, or go backward. Use a queue when you need to process things in the exact order they arrive, like in job processing or messaging systems. Both of them are simple in design, but they power many of the complex features we use every day. Now you know what stack and queue are, how they work, and how to implement them in JavaScript. Try building your own versions and play around with different use cases, like simulating a print queue or building a back button feature with a stack. The more you use them, the more natural they'll feel. If this video helped you, give it a like and subscribe so you don't miss any future coding tutorials. Thanks so much for watching, and I'll see you in the next video.